We're going to continue with sets, and we're going to talk about how do we compare sets. So how do I know two things are compared? And really, I'm going to use a Venn diagram to make that comparison because it's not always easy to tell if I'm just physically looking at a set. So two sets are equal if they have the same members. They can be written in any order, but the items inside the set have to be exactly the same, just in different orders. So if I look at the set in part A, if I look at these two sets, Facebook, Flickr, Twitter, Pinterest, Instagram, Vine, and then I look at the second set, they have the same elements, but just in different order, so therefore they're equal. If I look at A and B, I'm having to determine are the same people in both groups. And the answer is no, because I have a counter example that Arnold Schwarzenegger is a citizen of the U.S., but he wasn't born here. And so because I can think of one counterexample, they're not equal. Because remember, anytime we say equal in math, we mean they're equal all the time. And so equivalent sets don't correspond piece by piece. They correspond if they were in different orders so that they're mapped exactly the same. So they're the same if they have the same number of elements in them and the elements themselves are the same. So if I'm looking to distinguish between those sets, if I look at set A, it's pretty clear the second set has more elements in it. So that means that repetition doesn't increase the numbers, so there's more elements, so my gut is to say, no, they're not the same. But if you notice, D occurs twice, and so if I rule out D and C, because they occur twice, I actually have the same elements in a different order. And so these are equivalent sets. Even though the number of items is off, the exception to the rule of number of items is that if something is repeated, we don't write it twice in set notation. In these sets, they have the same number of items in them, but the items themselves are different. So they're not equivalent sets. And so a subset then would be the set that is inside of another set. And we indicate a subset by using this sideways U. And so we say that A is a subset of B, is what this notation means. This means A is not a subset of B. This is really hard to understand without an example. So I'm going to give you some examples. If I'm using that analogies principle and I'm trying to suss out what does it mean to be a subset, we would expect a subset to have all the characteristics of the starting set. So if I have 1, 2, and 3 are in A, and B has 1, 2, 3, and 4, every member of group A is found in group B. So A is a subset of B. If I look at B, it has an extra number, so B cannot be a subset of A. And the second group, I have a list of people, and I'm wondering, have these people won Emmys? So I'm going to go Google and I'm going to find out, did all of these people win an Emmy? And I find out, yeah, everyone in group A won an Emmy. So I can say that A is a subset of E. But if I think about people who won Emmys, that's a huge list of people. And the set A doesn't have a huge list of people. So not everybody that's ever won an Emmy is in group A. So then A cannot be a subset of B. They have to share those characteristics. And a Venn diagram is really the best way to show subsets because there's an intersection there. And if A is a proper actual subset of B, but it doesn't equal B, so meaning they're not exactly equal, but they have the same characteristics, then I would leave off the underline and just say A is a subset of B. And then this would be A is not a subset of B. And it's not a proper subset because they're not equal groups. So if I'm looking at this given problem, I'm considering the medalist winners at the 2014 games. I'm assuming that there's a universal set of everybody who's won, and then I have these other subsets that are following through. And it says which of these statements are true. So I've got the events and the medals and the countries listed out so that I can make sure I'm matching up my information that I was given. And if I look at A is a subset of G, because Kearney is a member of A, but he's not found in set G, the set of all gold medal winners. If I look at is N a subset of B, well, let's see. N stands for the Norwegian athletes. So I'm going to go to athletes. I'm going to check out the Norwegian people from Norway. So I see I have Henrik and I have Martin. And I'm trying to see if they are a member of set B, the bronze medal winners. Well, if I look at Norway, they both took a bronze. So yes, every member of N is also a member of B. So it is a subset. Now remember, this one says that N is a proper subset of B. And I know that's true because B contains Kearney, who is not an N. So I can say that N is a subset of B, but not vice versa. B is not a subset of N because I have a bronze winner that's not from Norway. So the number of subsets can get kind of confusing. A set that has 5 elements would have 2 to the 5th subsets. So 2 times 2 times 2 times 2 times 2. And that's how I can get a numerical value for the number of subsets within a set.